Next, we're looking at add and subtract complex numbers. So if we are given these numbers here, all we have to do is add and subtract. So please note, we are adding and subtracting complex numbers. There are no dots between them, which means we are not multiplying. So the first step would be to break the square root of -4 into root -1 times root 4. This would be our first step. Plus, same thing with the 16, because there's a negative under the square root sign, we'll need to make it square root -1 square root 16. So here we'll get minus root 81. Remove root -1. This is a mistake. So we'll have root 81, which means in the next step we're going to have 2i plus 4i minus 9. These are like terms, so 2i plus 4i will give us 6i, so we'll have minus 9 plus 6i. It's as simple as that. Let's do example B. We have a negative square root of -9 minus square root of -25 plus the square root of -64 minus the square root of -1. So the first one, we have our negative on the outside, breaking up the square root of -9 into square root of -1 square root 9 minus the square root of -1 square root of 25. If we multiply these two, we go right back to square root of -25. Now let's square root -64. We'll get square root -1 square root 64 minus square root -1 will be here, and that will give us square root of -1. Okay, is it good so far? So square root of 9 is 3, and that will give us I, minus square root of 25 is 5i, because of the square root -1. The next one will be 8i minus the I. These are all like terms. So minus 3 minus 5 will give us -8. So negative 8i plus 8i minus I. Our answer will be minus I, because the minus 8i plus 8i will give us 0. So our answer here will be 0 minus I. So we're still with adding and subtracting complex numbers. So we can break up root -3 into root -1 root 3 plus root -1 16 root 3. Root 16 times root 3 will give us root 48. Does it make sense? So now all that's in orange will become i's. So we will get root 3i plus square root of 16 is 4 root 3i. So square root of 16 becomes 4 root 3, and this here is I. Notice we have a 1 in front of the root 3, so 1 plus 4 will give me 5. So that is that hidden 1 I always talk about. So 1 plus 4 is 3. Root 3 times root 3 plus root 3 will remain the same, because this is like terms. We are not multiplying. If this was multiplication, then root 3 times root 3 will become 3. In this case, it's like terms. So you have 1 root 3 plus 4 root 3 will give us 5 root 3 I. Because all of this at the back, the root 3i is like saying 1x plus 4x, because you are adding and not multiplying. So like terms come in with adding and subtracting. Pause the video and see if you can do D. So I helped you out with the first one. Root minus 12 is square root of minus 1 times 12. See if you can continue. Pause the video and try it. So now we have square roots of negative 36. Those will become square root of minus 1 times the square root of 36 plus the square root of minus 1 square root of 28. Next step would be to break up the root 12 into root 4 and root 3. Break up the root 36 into answer of 6, and root 28. 7 times 4 is 28. Okay, so breaking up the square root of 12, we get square root of 4 times square root of 3i plus the square root of 6i. And then for 28, we'll get root 4 root 7i. Square root of 4 in the next line, square root of 4 will give us 2 root 3i plus 6i plus 2 root 7i. So the square root of 4 is 2. Now notice here, these are all unlike because the back part is not the same. So notice here, we have 2 root 3, here we have 6, and here we have 2 root 7. So on a calculator, yes, we could add all of this up and say, well, I is the common one, right? But if we add it up, we're going to get a decimal answer. So I'm sure if you had to write out a decimal answer, it would still be correct because you're showing that the I is what makes it the like term. So consider this, that all of these are unlike roots, okay? So the root itself is unlike because we have root 7, here there's no root, and here we have root 3. So it's unlike roots. Do you agree? Even although the I is like, but it's unlike roots. So consider this example. We have AB plus AC plus AD. Notice that these are unlike terms because terms have to be like according to their variable. So notice AB is different from AC, is different from AD. But if you look at it more closely, it does have a common factor. You see? So it's unlike, but there is a common factor. If I remove the common factor, which is A, I'll be left with A plus B plus C. So let's apply this logic to this question at hand and remove the I so that we can write what's left. So those are all the numbers, and then we remove I. That's the final answer. In a nutshell, you are saying add up the roots and this number, and that will be a number altogether, I. Or if you had to punch all of that into your calculator, you'll get a decimal answer with I that follows. Both ways will be correct, but this is a more mathematical way. E. So in E's example, we have imaginary numbers again. Don't forget, our whole topic is imaginary numbers. So here you will break it up into square root minus 1, square root minus 1 in the denominator plus square root minus 1. I'm sure you get the picture. So it'll be square root minus 1 times 18, square root minus 1 times root 2, and this other one on the right hand side is going to be square root minus 1, 144, square root 144. So now we can simplify this, okay, and see if we can get a solution. So we'll break this up into square root 9, square root 2. In the denominator, we're going to have square root of 2i, and here we are going to get 12. So the square root of 144 is 12, and square root of minus 1 is always I. Notice here on the left hand side we can cancel because it's all multiplication there in the first fraction. So the square root of 9 is 3, and we have exactly root 2 over root 2, and we also have I over I, plus 12i. Cancel all that. We're going to get 3 plus 12i. That's the final answer.